Folks, hello. We are going to be doing section 5.3. Now, this is not chapter 5 from your textbook. This is chapter 5 from the Algebra 2 textbook because we're going to be revisiting some of the things you haven't seen for a while, quadratics. We really need to cover these pretty well. So we are going to be giving you some supplementary material to use. It's going to be a PDF on the website that will have chapter 5 from the Algebra 2 textbook. So one is going to be done through PDF, so that just so you're aware, that will be on our Schoology sites, and you'll find the material there. And so let's go over to our notebook, and we'll get started. All right, so this is 5-3 again from the Algebra 2 text, solving quadratic equations by factoring. This is incredibly important, folks. It has to be almost a second nature type of skill. And I know every year we go through this. You have seen factoring a couple times already. And for most of you, it was something you just survived. You didn't really internalize it. And we understand that. So I'm going to start from absolute basics and work my way forward. And I'm also going to show you a way you probably haven't seen before called the magic method of factoring for that lovely quadratic that doesn't have 1 in front of the x squared when you've got something like 2x squared and a trinomial. So we're going to look at some of these different methods. And I'm just going to do a bunch of examples for you, really. I think it's the easiest way to see how this is done and how the different strategies can work. So enough talking, let's get started. I'm going to show you the first example. Now, you know what, before I do that, I should write down what you're going to see as your directions. The directions are going to say, well, they're going to say something like this: solve by factoring. All right, this is what the problem directions will be, the instructions. And they may give you something like this. They'll say 3x squared equals 15x. And again, these aren't the type of problems a lot of times you saw when you did quadratics. And you have to be able to look at it and always say, all right, if I am going to solve by factoring and it's a quadratic. Now, we know that this has the potential to be a quadratic equation, or it is a quadratic equation because the highest degree is 2 on the variable. All right, so we know this is going to be a quadratic. The first strategy, the first thing you should always think of, and I'm going to write this over here, the first thing you should always think of is set it equal to 0. I'm just going to shorthand it, set equal to 0. So what I want to do is subtract 15x from each side, and I want this to be 3x squared minus 15x equals 0. You want to look at that equation in that way. All right, now I'm looking at this, I got it set equal to 0. The next thing you should always think of if you're solving by factoring is there a common factor? Right, this is critical to doing anything we're going to do. You always have to look for the terms that are all on one side now. They should all be on one side, 0 on the other. Is there anything that's in both of these? All right, so I look at the numbers first. If I look at the numbers here, I have a 3 and a 15. What I see that as is there's a 3 in each one of them. So I'm going to write that 3 down. I look at the variables in it. There's an x in this one. There's an x in that one. The lowest power is what I want to take. The lowest power of x in these two terms is x to the first. So I'm going to use that. And then I make a parenthesis. And what I'm going to do is divide each of these by this now. 3x into this. In other words, I'm thinking of it this way. 3x squared over 3x. That would cancel. That would cancel. So it'll leave me just x, right? And you can always test it. If I multiply this times this, I should get that. Then I'm going to divide 15x by, or negative 15x by 3x, and I get a negative 5, right? And now I have a common factor out of here. So I have a factored form at this point. There's nothing else I can do. There's nothing I can factor out of this. There's nothing I can factor out of that. So we have our factored form for this one. And now what do we do with that? The idea is to solve. So the thought behind this, guys, and I don't know if it's ever been explained to you, because every year I'm a little surprised when I talk about this. The reason we want this factored form is we have two things being multiplied set equal to 0 now. So think about what that means. If I have two numbers, if I have anything like a times b, let's just do this over to the side here, some other scribble. If I do ab equals 0, what do I know about either a or b? If these two things multiplied equals 0, then either this is 0 or this is 0, right? So there's two ways this could be a true statement right now. It could be true if 3x equals 0, because if 3x equals 0, then 0 times whatever this is would equal 0. Or it would be true if x minus 5 equals 0 for the same reason. If x minus 5 is 0, then x minus this 0 times this, whatever this number would end up being, would equal 0. So that's why we want to get it in a factored form, because it's multiplication and it's equal to 0. So then we just have to find out where each piece that's being multiplied is equal to 0, and we have all our solutions for this equation, for that original one we started with. So this is going to be true when x equals 0. There's one of our solutions. And this is going to be true when I add 5 to each side, I get x equals 5. So these are my two solutions for this equation. 3x squared equals 15x. X has to equal 0 or 5. All right. Again, just a kind of a basic start, but I always try to start with kind of the simplest way you could see something like this. And so what would we write for the last step? Is set each factor equal to 0. All right, so that's how. So common factor, I should have mentioned there is kind of an in-between step here, if we want to call it 2a. If you have to factor, if there's no common factor, you try to factor the quadratic, and you'll see that in the next one. We'll kind of cross that bridge when we come to it. All right. So now our next one, again, solved by factoring. The next example I'm going to give you is the ones you guys generally like. And you might have different methods of doing this, guys. And by all means, if you have a method that successfully gets you an answer every time, if you use the box method, the mom method, whatever it may be, stick to it. You don't have to do it my way. I'm showing you a way that I've found for those that have struggled or haven't found any other way. This seems to be the one way that I almost universally can teach just about anyone to do. So this is called the magic method. And with the one in front, it's really not different than anything you've probably ever seen. But you'll see as we evolve through this how it could be different. First off, this problem, if we're given this, the first thing I said to do every time is what? First thing is always going to be set it equal to 0. It's equal to 0. We're already in good form. We can see that this quadratic is equal to 0. So we have a quadratic equal to 0. Next thing, is there a common factor? I look. There's no number, there's a 1, a -10, and a 21. There's no common factor to those. The variables, there's an x here, but no x here. So there's not a common variable. There's no common factor here. So now we're left with a trinomial. With a trinomial, we have, in a quadratic trinomial, if we're going to be able to factor this, what we need, and this is always of the form when it goes 2, 1, 0 in terms of the degree, that's important as well. The degree has to go down 2, 1, 0, or it can go down 4, 2, 0. It has to start at a quadratic level, go half of that, and then down to 0. All right, so how do we factor this? Well, the way I show is this. Multiply this number, which we consider to be a 1, times this number, and you get positive 21. So for positive 21 now, I want factors of 21 that add to -10. So factors of 21. Now, what I first do is just start with 1 and 21. 2 doesn't go into 21, 3 does, so 3 and 7. 4 doesn't go in, 5 doesn't go in, 6 doesn't go in, then we're back to 7. So these are the factors. So are there factors here that would add to -10? Yes, with the right sign on them, they could multiply to 21 and add to -10. And that would be if I have -3 and -7. These multiply to equal 21. They add to equal -10. Now, how do I finish this? Well, I'm going to factor now. Factoring, I make two kind of binomial parentheses enclosure. I put whatever's here without the squared. And then I put these two terms, -3, -7. And those are still equal to 0. Again, we've reached that step. We've factored this now. And so we looked, it was equal to 0. There was no common factor. That 2a, or that you could call it a new third step, is can I factor this as a trinomial? I can. So I factor that. Now we've gotten to that point where, again, we've got things multiplied equal to 0. So I just set each thing equal to 0. And I solve that. So the solutions here would be x equals 3 and x equals 7. And we have our solutions. Okay. I'm going to keep moving. Another example. Let's see. Let's do some of the ones that usually trip you up. Let's look at something like, let's do this one. We'll start out with something basic. 4x squared plus 27x minus 7 equals 0. All right. So this is where most of the time I see people just want to start crying because they aren't sure because of this 4 in front what to do. Because the first step, it is set equal to 0. We're all good there. Common factor, again, 4, 27, and 7 don't have a common factor. There's not a variable that's the same in all these. I always go through that checklist in my head before I go to factoring. Now I look at this. There's not a 1 in front. So what I did last time is going to look a little different, but it's the same process. I'm going to take this number and multiply them. Negative 7 and 4 give me a negative 28. Now I need factors of this that add to positive 27. So think about what we have. Again, I start with 1, goes in 28 times. 2 goes into 14 times. Let's see, 3 doesn't go in, 4 goes in 7 times, 5 and 6 don't. So these are our factors. So I need these pair of numbers here that multiply to negative 28, but add to positive 27. Well, it looks like there's a difference of 27 right here. So if I do positive 28 and negative 1, it would work, right? So this is where the magic comes in, guys. This is what this is what I'm gonna call the magic method. I'm not calling it that. I didn't create this. It was called the magic method. What you do is take this. Again, we take this without the squared and put it in our parentheses to set up our binomials. All right, we do this. And we take these numbers, minus 1, positive 28. Now, if you know what you're doing here, you know this is not an answer. Because when I do 4x times 4x, I get 16x squared, not 4x squared. This is where the magic comes in. This is where the magic step is. It's right in the middle here. After I get this step, all right, again, just to recap, I multiply these two, I get my number. This number I need to factor. When I get the factors, I try to find ones that add to this number, all right? I find that, I take this value without the squared, put it in both the parentheses, and then I put my factors that work. Now, I look at 4x minus 1 and say, can I factor anything out of here? Is there a common factor? No. So this one's going to stay the same. There's nothing I can take out of 4x and 1 other than 1, and it doesn't change it. Now, if I look at this, is there anything I can take out of 4x and 28? Well, 4, right? 4 goes into both of them. So this is the magic. You wave your magic wand. I'll just do this. Waving my magic wand, I'm going to make every 4 disappear. So if I make 4 disappear out of this, I have an x left. If I have 4 disappear out of positive 28, I got a 7 left. And now if you check this, 4 times x is 4x squared. 4x times 27 is 28x. Negative 1 times x is negative x, so that adds to my 27x. Negative 1 and 7 make negative 7. It's magic. It works every time. So now we've got a factored form. We go back to what I said last time. Now I say, where is this one equal to 0? Where is this one equal to 0? When we know that, we got our answers. So let's solve that. So I look at this and I say, all right, I'm going to add 1. That'll give me 4x equals 1. Divide by 4, x equals 1/4. There's one of my solutions right there. Then I go over here, x equals negative 7. I got both my answers, and I'm done. It's simply magic. All right, we're going to do another one or two, just so you can see how this works, guys. It'll always work. Now, you do have to go through the steps. Got to take out any common factors, all that kind of good stuff, but it will work. Let's do this one. Let's do 12x squared minus 8x plus 1 equals 0. Again, first thing I always do is the set equal to 0. Yes. All right, I've got all my terms on one side, 0 on the other. Second thing, is there a common factor? 12, 8, and 1. It looked at first like there might have been with 12 and 8, but there isn't because 1 doesn't have anything in common with those other than 1. Variables, x squared, x, no x. So nothing there to take out as a common factor. So now we have to look at, can I factor this? All right, so I'm going to go through my magic steps. I got a positive 12. Factors of positive 12, 1 and 12, 2 and 6, 3 and 4, right? So are any of these pairs that would add up, if they multiplied to 12, would add to negative 8? Looks like here, right? If these were both negative, negative 2 and negative 6 multiplied give me a positive 12, and negative 2 and negative 6 added give me a negative 8x. So I go through my steps now. 12x 12x, and I put a -2 and a -6. And finally, I get to my factored form. It's important you get to this next step, guys. I got to see your factored form in this so that you can get credit. All right, so let's look at this. I look at this one now. Is there anything common here? Looks like a 2 in each of these. So I'm going to wave the wand, make the 2 go away, and I end up with 6x minus 1. I divide both of these by 2, in other words, right? Because there's a 2 in each one of them. So magically, I make a 2 factor disappear, and I get this. Same thing here. I look at this, 12 and 6. Well, 6 is a common factor, so I make 6 disappear from both of these. That would give me a 2x here and a 1 here. And now I have everything I need. Now this works to give me everything I wanted up here. This would be an equivalent form of this quadratic, just in factored form, right? So now 6x minus 1 equals 0. Means 6x equals 1, which means that x equals 1/6. We got one of our solutions. Now we go over here, 2x minus 1 equals 0. So 2x equals 1, x equals 1/2. So this is a way of factoring, and then you use the factoring to solve, all right? So we'll be asking you sometimes just give me the factored form. So we may just be asking for this factored form. Sometimes we'll be asking for solutions. If we want solutions, you got to go all the way down to here. All right, let's do another one. Let me make it a little bit different. We'll do one last one here, and then I'm going to set you free to do some homework. So let's look at this. 12x squared plus 18x plus 6 equals 0. So now, again, don't ever forget these steps. First thing, is it equal to 0? Yes, everything's on one side. Second thing, is there a common factor? Very important. Yes, there is a common factor. The numbers 12, 18, and 6 share a common factor of 6. There's no common variable, but I can take 6 out of this whole thing. If I take 6 out, I got 2x squared plus 3x plus 1 equals 0. And I got that step done. Now I look at this and say, what's inside here? I shouldn't see any common factors left. If I did this right, the first step right, there shouldn't be any common factor left in here, and there isn't. 2, 3, and 1 don't share a common factor. X squared x and no x, no common factor. So now I got to look, can I factor this? So this one I do again, positive 2. Factors of positive 2 that add to positive 3. Well, right off the bat, I look at and I got 3 and 1. Well, 1 and 2. I don't know where my brain went there for a second. Sorry. This is about, well, 6:30 at night, so I guess my brain's a little tired. What do we got? This is 1 and 2 would multiply to 2, and that's all only ones they have. And they also add to 3, so we're going to use 1 and 2. So I keep the 6. This is still part of the factored form. Don't forget it. It's there, right? I bring that down. Now I look at this. I'm going to put 2x. Remember, we got to start there. And then I'm going to put, this is going to be a positive 1 and a positive 2. So I'm going to put positive 1 and a positive 2. And again, this is not true right now. We've got to get back to this form. So I've got to go through the magic. Magically, is there anything I can take out of 2x plus 1? No. So 2x plus 1 stays 2x plus 1. 2x plus 2, I can take a 2 out of both of those. So wave your wand, make a 2 go away, and I get x plus 1. I've got the factored form here now. So we are factored. These three things multiplied equals 0. This one can't equal 0, so I just have to set this one equal to 0 if I'm solving, and this one equal to 0 if I'm solving. And I would get 2x equals -1, x equals -1/2, and we've got an answer. X equal to -1. We got another answer. We're good to go. This is easy peasy, right? You can do this. So that's what we're doing today. We are going to be starting by solving quadratic equations by factoring. We've got one other thing we're going to go backwards on, all right? And I'm just going to put it in this lesson because right now I think we're at about 20 minutes. You know what? We're going to break that into the next lesson. I'm going to do a second lesson that will give you the reverse of this, where we're going to give you these things down here, and we're going to want you to give us that thing up at the top. We're going to go backwards next time. All right? So stay tuned for part 2, and I will be right back with that. If I can stop the recording here. I got it. All right.